A geometric distribution is a discrete probability distribution of a random variable that satisfies the following conditions. One, a trial is repeated until a success occurs. So we keep trying, we keep selecting until we get what we want. So let me just underline geometric distribution. Okay, going to the next page. So that was the first condition. A trial is repeated until a success occurs. Two, trials are independent of each other. So one trial doesn't add or subtract anything from the second or third trial. They're independent. Three, the probability of success P is the same for each trial. So the probability remains the same. And finally, four, X represents the number of trials in which the first success occurs. So let's say that if you think of a basketball player that has, let's say, 80% chance of making a basket in every shot. So, this person keeps shooting until the first basket is made. All right. Let's go to the next page. Here's a formula for geometric distribution. P of X equals P times Q to the power of X minus 1 when Q is the complement of P. So if P is 80% 0.8, Q is 20% 0.2. All right, let's go to our example. So 22% of former smokers said they tried to quit 4 times before they were habit-free. 10 former smokers are randomly selected. Find the probability that first person who tried to quit 4 or more times is, go to the next page, part A, the third person selected. So what's the probability that, you pick one smoker and this smoker didn't have to quit 4 times. Then you pick another one. Now, what's the probability that the success happens on the third person? So the third person that you pick is a person who had to try to quit 4 times. Part B, the 4th or 5th person. Part C, not one of the first 7 people selected. So let's go to the next page and do first part A, the third person selected. So part A, we said a third person selected. All right, using a formula, we know that according to this example, we said that 22% of former smokers, so P equals 0.22. Therefore, Q is 1 minus that, so that gives me 0.78. All right. So we know that P of X is P times Q to the power of X minus 1. So P of 3, the third person, equals 0.22 times the Q, which is 0.78 to the power of 3 minus 1, which is a 2. Okay, I already put that in my calculator. And according to my calculator, that is 0.1338 or 13.38% probability that the third person you selected has tried to quit smoking 4 times before being able to quit for good. All right, let's go to part B. We said part B, the 4th or 5th person, the 4th or 5th person. So now I can say P of 4 or 5 equals P of 4 plus P of 5. Okay, so, and that equals 0.22, 0.78, so I have 4 minus 1 plus 0.22 times 0.78, which is my Q, to the power of this time 5 minus 1. Okay, to 4 decimal degrees on my calculator, with approximately 0.1858 or 18.58%, 18.58% chance that the 4th or 5th person had to try to quit 4 times before they were successful. Part C is asking not, we said not one of the first 7 people. Okay, what does that mean? So that means that the 8th person or the 9th person or the 10th person. So this is going, I'm going to write this as P of X to be greater than 7 equals greater than 7, P of 8 plus P of 9 plus P of 10. So now that equals 0.22 times 0.78 to the power of 8 minus 1 plus 0.22 times 0.78 to the power of 9 minus 1 and plus 0.22 times 0.78 to the power of 10 minus 1. And according to my calculator, I already have that at 0.09 229 and on. So to 4 decimal degrees, I have 0.0923, or now if I multiply this by 100, I get 9.23% chance that none of the first 7 people had to try to quit 4 times. Okay, I hope you find this example helpful.